So after 2 nights of setting up and not being able to get anything because it was cloudy, it's clear tonight, at least for now. So I'm taking advantage of that. Managed to get set up early. I got polar aligned. Everything was well and smooth. So now I'm going to capture 2 hours on the Triangulum Galaxy, and then I'm going to hopefully get another hour on the Pleiades to add to the project that I'm already doing, where I've already got almost 2 hours of data on that already. And then by the time I've got an hour on Pleiades, I should be able to then turn to Orion and start gathering some more data there on the Orion Nebulae, again to add to what I've already started collecting on that. So hopefully in for quite a action-packed evening, make the most of the clear skies, collect what I can, and add it to data that I've already collected over previous nights. So we've got our first images coming in here from the Triangulum Galaxy. There it is. So you can see how I've planned out my session here in our sequencer. You see we've started gathering this now just after it's got properly dark. So we've got 2 hours on this, which would take us to around 2100 hours here, and then we'll be switching to Pleiades. So I'm going to get that loaded up now and added here into the sequencer, so that it'll just continue on, should automatically re-slew and start capturing Pleiades after we've done our 2 hours here on Triangulum. So I managed around 48 minutes on the Triangulum Galaxy before I've got a little part of the roof of the house that sticks out, and it just was disappearing behind there. So I have transitioned now instead to collect some more data on the Andromeda Galaxy. I think I can probably get an hour on that. Then I'll go back to Triangulum, as it will have passed that part of the house by then, and should be able to pick up a little bit more time on that. Now it will eat into some of the time I was planning on getting on the Pleiades, but that's okay, as I already have a relatively good amount of data on Pleiades. So if I have to cut that short, it's okay. If I can get another half an hour, I'll be happy. So we got our first images coming in now from Andromeda. As you would expect, it's one of our nearest, it is the nearest galaxy to us, so it comes out pretty large. It fills the frame. And I think I should be able to get a wonderful image of this. Just have to collect enough data. That's really what deep spy astrophotography comes down to. Time on the targets, collecting enough data, making sure you're in focus, making sure your guiding's good. Once you got all those basics down, it's just a matter of time and patience. Clear nights, spending as much time as you can on specific targets that you're working on, and building up that data so you can get more and more detail in your images, less and less noise, and bring out some of those fainter details that are there lurking in the background. So this was Deep Sky Stacker Live. This was what we got so far on the Triangulum Galaxy. So we got some detail there, as you can see. And when we stretch this image, we'll be able to get something out of it. But I definitely need to collect more data on there. That's only 48 minutes so far. And then here is our first images coming in there from Andromeda. You can see, as I said, it's a huge galaxy. It really fills up the space. I think I've got a dust mote there on my image, which is a little bit unfortunate. Should have cleaned the camera before I started imaging. But anyway, we can sort that out a little bit in post later on. Hi guys, so I'm going to be continuing my shooting on Andromeda. So it's clear over in this patch of sky here, which is about where Andromeda will be when the sun goes down. So I'm going to go ahead now, get the telescope out, get everything set up, and continue our imaging. So I got about an hour or so, I think almost 2 hours on it last night. You can see the picture here. So we're going to collect some more data on it tonight, add that to what we've already got, and see if we can just bring out some more of those details there in the Andromeda Galaxy. And it's really amazing that you can actually get such details on the galaxy from your backyard. When I first got into this hobby, I really didn't believe that some of the images I was seeing were being captured by amateur people such as myself from their backyards. You know, you think they're coming from the Hubble Space Telescope or the James Webb or something like that. So let's go ahead, get the telescope out, get it set up, and hopefully the clouds do stay away. There are some over there on the distance, but over here right now it is clear, and that is where Andromeda is going to be. For those of you who haven't seen videos before and know about the setup, this is what we're imaging through. So we're capturing Andromeda through this telescope here. This is a 80mm aperture. So the aperture is the size of the front here. Now this is the light gathering capabilities. The bigger the aperture, the more light you're going to be able to gather. The longer the telescope, the longer the focal length, the more zoom you're going to get. So you can have a big aperture and a short scope, which will give you lots of light gathering, but doesn't zoom in very much. And that kind of is what we need for these deep sky images, right? What we're capturing are actually quite huge. You know, bigger than the, in terms of size and space they take up in the sky, they take up more space than the moon. So you don't need something that is zooming in, a really powerful telescope. You know, that's if you want to see very distant galaxies, if you want to get onto planets. But for what we're getting, these kind of either, you know, nearer galaxies, which are a bit larger, and the large nebulae that we've got out there, we don't need a very, very long telescope. In fact, when you're starting out, a longer telescope is going to be more difficult for you because everything gets magnified. When you increase your magnification, any errors, any wind, it all gets magnified so much more. So it's easier to learn with a setup like this. So we've got our tracking mount. This is a go-to mount. We can point it to the object we want. It will track it. So that means that the mount will actually turn in time with the rotation of the Earth. But then for more accurate, longer exposures, we need guiding. So that's what this here is for. This is our guide camera and our guide scope. So this will lock on to a few of the stars that it can see, and it will send commands to our motorized mount here to make sure that that star stays in the same field of view, stays in the same position, and it just allows us to do longer exposures. Now coming back here, I've got a filter drawer here, so this is where I can change out filters. For Andromeda, I am going to be using a UV IR filter, so I need to replace the one that's in here right now, which is our dual band filter. So this is a dual band filter, so it doesn't let a lot through, it's very reflective. That dual band filter is for when I'm doing nebulae. I'll be using this later on the Rosette Nebulae. If it remains clear, I need to get some more data on that. So I'm not going to use that for Andromeda tonight. I'm going to just use my UV IR cut filter. I may do some imaging of Andromeda using that filter later on if I get another clear night, just to finish off the project. Okay, so let's get everything plugged in. So all this plugs in. We've got power for the cameras, we've got power for the scope, for the guide camera, we've got power for the laptop, and we also have power for the tracking mount. So all that needs plugging in. We'll get it connected up to the computer, and as soon as we start to see some stars coming out in the sky, which we will do in a few moments, you can see the sun's going down, then we will get polar aligned and get up onto Andromeda, which is around that area right now, and start imaging it. Okay, so while we're waiting for it to get dark and I can start my polar alignment, I'll just take you through the kind of software setup I've got here and the laptop. So typically I'm a Mac user. It is possible to do astrophotography through a Mac, but there's just not so much good support and software. So I brought a Windows laptop. It doesn't have to be powerful. It's a pretty basic laptop just to run the imaging session. And I use three main pieces of software here, which is Nina, Deep Sky Stacker, and Stellarium. So Deep Sky Stacker is what I use to stack the images. Stellarium is what I use as kind of my software to find the targets and plan what it is I'm going to shoot. So if we open up Stellarium is pretty neat. It you know, basically just shows you the position of various targets at this time and location that you're at. And then it interfaces to Nina. So it can grab from there the target, it can slew the telescope onto target and get aligned, and then you can start imaging. So Stellarium is a really useful tool, and most of the software is all freeware, okay? So Stellarium is free, Nina is free, and that's what I use for running the actual session. So I'm going to get those started up. Oh, and I also use PhD2, which is the software that controls the guiding. All right, so let's get our mount turned on. So we'll get that powered on, and then I'm going to get the cameras cooled. So I use a deep sky astrophotography camera from SV Bonney, matches the telescope. SV Bonney also. It's the 405cc. It's a one-shot color camera. So that's what I use, and it's a cooled camera. That means you can cool it down to about 30 degrees below ambient. Here in the Philippines, as you can tell, I'm in a tropical kind of environment here. So I can get that down to about -5. If you're in colder countries, you can get it down to -10 and lower. The lower you get that CCD temperature, the less noisy your images are going to be. So I've got the camera there, and that interface is to here. So what I'm going to do is get it cooled down. So once I get Nina started up, I go ahead and I connect it to everything. So I connect all devices. So I've already saved the profile of everything that I've got that I use here with Nina, and then I go ahead and connect everything up. So we choose our camera. That's the 405C, and we just go ahead and get that connected. So once all of our devices are connected, I have these all running through a USB hub, okay? So I've got one USB cable that comes back to this hub here. It's a powered hub, and this is the two cameras and the mount. So the two cameras, the guide camera, the main camera, and the mount, they go into that USB hub, and it comes back here. Now, the USB hub does have additional ports available if I'm shooting in a colder environment. Again, I'm in the Philippines, so not very often, but we do have some mountainous areas where it can be cooler. I may want to use a dew heater, so I haven't used those yet. I've got them, but they're basically some bands that you strap around this telescope here, and they generate a little bit of heat, and they just help to stop dew from forming, fogging up your lenses. So I do have provision to plug those in if needed. Okay, so I've got that connected up now in Nina here. And I'm going to go ahead and turn on my cooling. So I don't want to go straight down to -5. I cool in stages because of the humidity here. If I cool too quickly, I get, again, fog on the actual CCD of the camera itself. So I'm going to go ahead. You can see it's 26.3 degrees ambient right now. I'm going to cool down over a period of 5 minutes down to 10 degrees C. And then over 5 minutes, I'll go down to 0. And then over another 5 minutes, I'll go down to -5. So that takes a little bit of time, but it's okay. I have the time for this to all kind of take place while I'm doing my polar alignment and everything else. So we've still got that patch of clear sky there, and the first bright object is now visible. Up there is Jupiter. I don't think it's coming out on my camera here, but I can see its light shining. So probably now another 30 minutes, it'll be dark enough to start imaging. Maybe another 15 minutes, we might be able to see enough stars to get a decent polar alignment. Okay, so here in Nina, I'm going to load a target set. This will be the Andromeda Galaxy that we were already filming. So the targets here, I'm going to go to Andromeda. So this is going to bring up all of the parameters from our capture session last night. So our camera rotation, the angle the camera was at, shows you where Andromeda is now in the sky, when it's going to disappear, what our imaging session yesterday was. So we had a gain of 110, we did 120-second exposures, we did 60 of them, so that's 2 hours. I'm going to reset this. Okay, so we did this yesterday, and what I am going to do is basically try and image again another 2 hours of 120-second exposures, and add that to the data that we already collected last night. Once it gets dark enough, we will be using this to get set up and framed to try and match the frame that we had yesterday. So what we'll do is we'll click on send coordinates to framing wizard. That'll send them over to here. Now what Nina's framing wizard is going to then load up an image of Andromeda, centered exactly the same, framed up the same way that we had yesterday. And then once we get student centered on the target, which we'll be able to do once it gets dark enough and we've done our polar alignment, we can determine the camera rotation. We can turn the camera around so it matches the rotation that we had yesterday, which was 65.89 degrees. And then we should be able to match up pretty closely to the same framing that we had yesterday. Okay, so it's got dark enough now to do our polar alignment. This is taking our third reading now. So here we are in Nina doing our 3-point polar alignment as per our usual process. It's going to tell us our total error. Okay, so not too much. We need to move a little bit to the left, 1 degree 57 seconds. So we make our adjustment, get this as close, total error as close to 0 as we can, and then we're good to go. There we go, we're done with our polar alignment. Total errors pretty low. And now we'll get framed upon target. So I captured some more data here on the Triangulum Galaxy, and you can see now we're starting to get this shadow at the corner here. That's actually the edge of our house. So we're going to have to stop imaging here now, as we're starting to catch the edge of the roof. So we'll go over here and we'll hit stop. So we were able to get 21 images, and I believe last night I also got around 21 images. So we'll just keep on adding these up each night, as we only get a limited amount of time on this particular target before it hits that corner of the house. The good thing is Andromeda was hidden by that same piece of roof while we're imaging Triangulum, and now Andromeda has dropped below it, so we can switch straight over now to Andromeda. So what we're going to do is we'll go back and open a target set, and we're going to get our Andromeda again, and then we'll send this to our framer. We'll turn off our guiding for the moment, so we stop guiding, and we'll go over here and we slew and center. Now we're going to have to rotate the camera because we have to frame this up. We need the camera rotated to 65.89 degrees. Now I don't have an automatic rotator called a field rotator, so I'm going to have to manually do that. So we'll just manually rotate the camera around, and we use this determine rotation from camera, and we'll use that to get as close a match as we can, so that we can continue imaging and stack those images on top of the ones we already got. And you can see here how bright Andromeda is. The core of the galaxy there is showing up, and it's just on a 2-second exposure. Just getting ourselves lined up. Okay, so now we're here. We will determine rotation of the camera. We're going to be about 101 degrees, because I think that's what I had for Triangulum. So we're going to have to rotate this, yeah, it's at 100 degrees, and we need to get it back to 65.89. So we'll just turn the camera around and get this lined up. So here's our images coming in now of Andromeda. These are 120-second exposures. 180-second exposures. So we're doing 3-minute exposures now. Yesterday we did 2 minutes, 120-second exposures. So we're going to mix the 3-minute and 2-minute exposures together, stack them all up. So we should be able to bring out kind of some of the fainter details, but the shorter exposures will help us with the core of the galaxy not overexposing that. So we've got a little bit of time still left on this. You see here in the sequencer, you can see where we are now, and it's going to start dipping down. It's going to be low in the sky soon, so I'm not sure if we'll be able to complete all of the frames I wanted to collect on this today, but we'll just take what we can. Now I need to shoot off some darks that match the 3-minute exposure for us to use in the stacking, and then tomorrow, if it's clear, then we can just continue capturing data on this every night and improving our image over the course of a few weeks.